Hi there, everybody. So we're going to start chapter 1 here. And this first section is called the structure of data. So it's really just an overview, just a basic overview of some of the terms and definitions we're going to use throughout the semester. Real short section. This video shouldn't take long. So let's get started. So the way that my PowerPoints are laid out, the first slide, other than the title slide, is always a list of goals. These section learning goals are the ones that correspond to the videos that I talked about in the last YouTube video. I told you that you can watch the videos in the ebook. Well, they always correspond to these section learning goals. So that's something that if you want more practice, you can investigate on your own. All right, so let's jump right in here. So the first two things we have to define are data and statistics. Most of you guys probably have seen these terms before, but because it is a math class, we have to be really technical, right? So data are measurements taken on a set of individual units. So that's just, as in all math classes, all the definitions are real technical. So notice it says measurements, right? That's important, right? And statistics, for our purposes early on in the class, is just the science of collecting, describing, and analyzing the data that's collected. And that's probably what you thought it was, right? But again, later on, we're going to have a different use of the word statistics. But for now, it's just the name of the course. And it turns out that in 2020, humans produce around 20 quintillion, so it's 2 times 10 to the 19th bytes of data. And that's about 2.6 billion bytes per person per day. So if you're wondering, why is everybody so concerned about data? Why is statistics such an important field? Right, it's the #1 math class at the community college, and it's because there's so much data, right? Every year, humans are producing more data than every year previously combined in human history. And you might say, well, how's that possible? Well, the two main reasons are smartphones and computers, right? So that's something important to think about. So early on in this class, I want to give you guys a reason to, #1, appreciate statistics, #2, possibly even enjoy it. So on the next slide, we're going to talk about that a little bit more. So it turns out there's a lot of jobs that use data every day. And so this list is available here at this link. So if you have downloaded the PowerPoint, you can just click on the links and it'll take you right to it. So I looked at the top 30 jobs in the US currently, and I picked the ones that use data, and I left medical doctors off the list intentionally. Just obviously medical doctors use data. But these are all jobs that you might not, just looking at the list, you might not know that these are all jobs that only require a 4-year degree, many of these. And these are very, very good jobs. They pay well, good job security, good hours, good work-life balance, things like that. And they all use data every day. And so statistics would be important for somebody going into any of these fields. So look at the list, find a couple jobs that you think you might want, and much later in the class, we're going to come back to this list. The lab 3 that you guys have, it's like 2 weeks from the end of the class. Your third lab is about jobs. So this is just something to think about. Maybe you know what you want to do when you graduate, and maybe you don't. And if you're not sure, any job on this list would be a great job. And if you have more questions, you can always check out the article. The full article is there. It explains all the jobs, the job outlook, what the people do, where the job centers are located, so what areas of the country are using those jobs and stuff. So something to think about. It's pretty cool. All right, let's keep going. Back to the technical stuff. So the data that we collect is information about cases, and they're sometimes called units or subjects, and generally record the information for each case in a row of a data table. So cases can be people, mice, or even US states. Anything that is directly studied in order to obtain data is a case. And so you might have heard this expression if you took a psychology class, maybe you've heard of a case study. That's what it means. A case is just whatever is being directly studied. And the variable is any characteristic that is observed for each case. And these variables generally correspond to the columns in a data table. And the value of the variable, the values of the variable are the numbers or categories that are recorded as data. So the idea here is that when we use data, and you're going to have 3 labs, your first 2 labs have data organized in this manner, what we're looking at here, where the cases are the rows and the variables are the columns. In any data set, it is important to understand exactly what each variable is measuring and how the values are coded. Because a lot of times the information is encoded and you're not given the full information. It might just be like a number that represents something else. And sometimes the names of the cases are not listed, and you'll need to read the study summary carefully to figure out who or what the cases are. This comes up a lot in the homework. You'll see it when you get to the homework. There's some challenging problems where you have to think about what would the data display look like in rows and columns, and kind of sketch it out on a piece of paper. For example, your data might consist of heights, weights, and GPAs. You need to determine that the cases are individual people. Right, so you might say to yourself, well, because you might not be given the cases, you might just be given numbers for heights, weights, and GPAs and kind of have to work backwards to figure out what the cases are. And additionally, a person's height is a variable. So every person has a different height. But if there's some particular person, Alex might be 71 inches tall. So the value of Alex's height is not a variable, right? Height, everybody's height is a variable, but for a particular person, the value of Alex's height is 71 inches. People get that mixed up a lot, so just keep that in the back of your mind as we go through. We're going to talk about variables. Variables are things that can be different for different people or different cases. Values are the individual numbers or categories that go into each subject's or each case's variable, column, and row. So this is what it looks like here, right? So here we have height, weight, and GPA, right, at the bottom. So this is this data set at the bottom is it was a high school student survey, and we'll talk more about this data set later. It's just a bunch of data that was collected on a bunch of high school students. And so this is a data set. Usually the data set is presented as a spreadsheet like you see at the bottom, right? Each case is a row, each variable is a column. Notice you're not told who the cases are here, right? You have to figure it out. Like, these are people. Do we know who they are? Do we know, which student is Alex? Well, maybe Alex is this first student right here, 71 inches tall, right? So a lot of times when we use data, it's anonymized, so we don't put the people's names on it, right? That makes sense. You still got to figure out that the cases are people, right? Cases are whoever or whatever is directly being studied. Anything else is a variable. So here our variables are year, gender, highest SAT score, GPA, number of siblings, height, weight. And then you can see other things. So these are kind of codes, right? So this just says exercise and there's a bunch of numbers. Well, what do you suppose that represents, Well, it turns out that this exercise, this is hours per week. So it is encoded, right? You got to kind of figure stuff out sometimes, right? Hours of TV watched per week, resting pulse rate, and which award would the student rather win? Olympic, Academy Award, Olympic gold medal, Academy Award, or Nobel Prize. So it's encoded, but we're still getting a lot of information here. It's pretty interesting data set. And I just went over this, right? So this list is very long. It's like 360 something students. And it's in the textbook. But it's just something to think about. All right, so let's look at types of variables. So variables come in a lot of different types. The first one is categorical variables. And a categorical variable divides the cases into groups. It just chops up all the cases and assembles them into little groups. So year in school, gender, higher SAT, and a word preference. Those are all categorical variables. And if we go back and look at the list, you can see why, right? Year in school chops it into categories. Gender chops into categories. So anything that has categories as opposed to measurements, right? This is not a measurement. What award you'd rather win. It's not a measurement. But something like height or weight is a measurement, so it's not categorical. And the things like height and weight are called quantitative variables because it is a measurement of a numerical quantity. So all the rest of the variables were quantitative, not because they were numbers, because they were measurements, right? SAT score is a measurement of how many questions you get right on the SAT. GPA is a measurement of the grades you've earned, right? It's measuring some quantity. Number of siblings, you're counting. Height, weight, obviously are measurements. And the other ones are measurements as well, even though these are sort of, well, this is like an opinion question because nobody's actually tracking it, but it's still a measurement. And resting pulse rate, of course, is a measurement. So that's the two big ones, right? Categorical, quantitative. Every variable in this class that we study for every day of this class till the end of the class is either categorical or quantitative. Now, there's two things that can go wrong with variables. As long as you're aware of this, you're going to be fine. The first one is that some variables could be categorical or quantitative depending on how the data are recorded. So year in school could be categorical, right? We saw that already. But it could be quantitative if the people collecting the data choose to register that as how many years of school have you completed. And if you say, I've completed 11 years of school, they would just call that a junior, right? But it's still a measurement if you would choose to obtain the data in that way. And second bullet, not all numeric values are quantitative. You have to be very, very careful about this. It's going to be on the exam. Do not miss it. Phone number, zip code, social security number are not measurements, so they are categorical, right? So quantitative does not mean number. It means measurement. So study that. Don't forget that. Okay, there's another way that we can describe variables, and that is the idea of the explanatory and response variables. So if we're using one variable to help us understand or predict values of another variable, we call the former the explanatory variable and the latter the response variable. So this is a very technical definition, right? Just make sure you know these vocab terms. This is very important. So here's an example at the bottom. Can the number of years playing football affect the size of the hippocampus region of the brain? So notice that's like a statistical question, and you could use data to answer that question. So we're trying to use one of the variables to predict or understand the other one. So the explanatory variable has to be the number of years playing football, because the idea would be that if there's an association between football and the size of the hippocampus region, it really only makes sense that playing football might somehow change the size of that region of the brain. It's not the other way around, right? Somebody's brain changing size doesn't make them go play football. So we want to understand the size of the hippocampus region of the brain, and we want to use number of years playing football to predict it. So if you're not sure which one is the explanatory and which one is the response, there's two things you can use. Number one, you can look for, does one cause the other to happen? So in this case, would playing football cause the hippocampus region to change size? And the other thing to look at is, which one is easier to measure? It's a lot easier to measure how many years somebody played football, so that would be the explanatory variable. Right? So there's two ways to remember it. All right, let's keep going. So using data to answer a question. Data can be used to answer interesting questions. So here's 4 examples that we're going to see later in this class. All of the ones on this slide are things we go into more detail later. Does caffeine increase the speed of a person's finger tapping? What is the difference in the proportion to use online dating between those with a college degree and those with a high school degree or less? What is the proportion of young people who have been arrested for a crime other than a traffic violation by the age of 23? And is exposure to pesticides related to the likelihood of an ADHD diagnosis? So this is just a few problems that I know we're going to be working on later in the class, and I just wanted to put them out there so you can think about them. And you can see how data would be used to answer all of these. And if you're not sure, just think about it. How would a researcher go collect data to learn about this stuff? Just try to imagine it, and then we'll cover all these things later in the class, either on the homework or in the lecture. So let's identify some variables. So here are 2. These are questions that can be answered with data, and we want to identify the response variable and the explanatory variable, and whether each is quantitative or categorical. So the first one here, do weightlifting exercises improve runners' 5-kilometer race times? And the second one, is there an association between smoking and survival rates over a 20-year period for women in the UK? All right, so let's look at the first one. So we need to identify the variables here. We don't see the data. This happens a lot in this class. You'll have to be able to draw conclusions with incomplete information. Here, all we're doing is identifying the variables now. So we have weightlifting exercises. That's related to one of the variables. And then we can see that there's a 5-kilometer race time, right? So which one do you think would be the explanatory and which one would be the response? Well, the idea here is that we think weightlifting exercises would cause the race times to improve. So the response variable would have to be the race times, and the explanatory would have to be the weightlifting exercises in some sense. It's not quite that simple. I'm going to show you on the next slide. And then which one of these is quantitative and which is categorical? Well, here's the thing. If weightlifting exercises is part of a variable, that means that there has to be some people given weightlifting exercises and other people that don't do them. So the category, so this would be categorical. It would be that would be a response variable. I'm sorry, your explanatory variable would be categorical. So the response variable is the change in each runner's 5K race time. This is a quantitative variable. It's a measurement. How fast did the person run? The explanatory variable is whether each runner lifted weights or not. That's categorical. So notice that lifting weights by itself is not a variable. A variable is something that could be different for different people in the study. Some people got to lift weights, other people didn't. You're not told that that's happening in this problem. You just have to think about the situation and go, if we're trying to measure if lifting weights helps people run faster, there'd have to be some people in the study who are not lifting weights, right? So again, we're getting incomplete information, but by the end of chapter 1, we'll understand this thing all the way through. This is still just introducing the ideas. All right, let's look at the second one. Smoking and survival rates. So again, we have categories here. People either smoke or they don't. So even though we're not told that there's a non-smoking group, there has to be a non-smoking group in this study because you have to compare things. And then survival rates. So a rate is what proportion of people survive, or what proportion of the women in the UK survive. So that means some people in this study died in a 20-year stretch of time, and other people didn't. So those are your 2 variables, right? So the response variable is whether each woman was deceased or still alive after 20 years. So notice it's a variable, so there's different categories, alive or not alive. This is categorical, and the explanatory variable is whether each woman smoked or not, also categorical. So categorical variables come in lots of different varieties. Usually what we measure is some kind of did this person do a thing or not do the thing? So it's a choice between usually two things, but it could be more. So here, all of our categorical variables are choices between two options. Lifted weights or not, deceased or still alive, smoked or not, right? Okay, well, that's it for this section. Not a ton of homework. You guys are going to want to get working on that homework as soon as you can. And you can work on it during class on Tuesday or Thursday. So here's some concepts to remember. This is just like a quick summary of what we studied. I'll let you guys read over that. And I did include, always the last slide is just some extra stuff you guys can work on. Video solutions for the book examples. So if you're flipping through the textbook or the ebook, all of the examples come with videos. So those are great. And the video tutorial for the learning goals, that's at the, I went over that in the previous video. That's at the end of the section. And of course, there's some book exercises. All of the odd exercises in the book have the answers. And many of these are, of course, homework problems. So you might as well just look at those and give yourself the answers to half of the homework problems, right? Can't beat it. All right, well, that's it for today. And until next video, study hard, and I'll see you guys in class. Bye-bye.